Hello everyone, this is Arif Nisartare, studying in EC 8th semester in Sri Venkateshwara College of Engineering. Today we are going to discuss about the development of an automated distribution grid with the application of new technologies. These are the contents which I am going to explain today. It includes introduction, history, objectives, methodology, block diagram, result, advantages and applications, its conclusions and references. Coming to the introduction part, the development of an automated distribution grid involves the implementation of advanced technologies such as smart sensors, machine learning algorithms, and automation softwares to optimize the distribution of electricity in more efficient, reliable, and cost-effective manner. This can improve the quality of services for customers and help utilities meeting the increasing demands. An automated distribution grid enables utilities to remotely monitor and control the flow of electricity through the grid, identifying potential issues before they become major problems and automatically taking corrective actions. It also helps to reduce the outage time, improve power quality, and increase the integration of renewable energy sources. The electricity distribution grid is one of the most vulnerable points in the electricity supply process. In some countries, approximately 80% of the power outages occur due to failures in the distribution system. This is due to this large extension and numerous derivations consisting of various devices and exposed in an environment that can cause defects. Many of these new automation elements are made possible through direct test on the grid itself. The use of renewable energy sources such as solar and wind power also requires an automated distribution grid that can manage fluctuations in power supply. Coming to the next history part, some of the old cicada systems were installed in the 1920s. At that time, some high voltage substations adjacent to power plant could be monitored and controlled from the power plant's control room. After that, in 1930s, individual utilities started interconnecting to interchange electricity to reduce operating costs. So analog computers were developed to monitor and control generator output, tie line power flows and frequency. After that in 1960s, digital computers and softwares were developed to replace the analog EMS system. These are the two figures which shows the old and the current control system. More recently, some utilities have deployed distribution control system with area transmission and distribution control center. Other utilities have also installed regional DMS which communicate with the distribution substations as well as the feeder devices. The objectives include understand the requirement of energy production and development to increase the efficiency and of energy system, to reduce the overall cost of energy production and distribution, to enhance the stability of the energy grid by managing energy supply and demand more effectively. Methodology. Developing a detailed system design that integrates the selected technologies into cohesive and effective distribution automation. The data collection will be done through the combination of primary and secondary sources. The primary source of data will include interview with the experts in the field, surveys with stakeholders, and field observations. The secondary source of data will include technical report, academic literature, and government policies. It has three main prototypes. One prototype development. The prototype of the development distribution grid will be deployed based on the selected technologies. The prototype will be tested in laboratory environment to ensure that it meets the desired specifications. Another is the field testing in a real world setting to evaluate its Eff- effectiveness in improving the reliability, efficiency, and sustainability of the distribution system. It will be the field testing will involve the development of prototype in the selected area of distribution system and the collection of data on its performance. Another is the data analysis. The data collected will be analyzed using descriptive statistics to determine the effectiveness of a automated distribution grid in improving the reliability, efficiency, and sustainability of the distribution system. The development of such grid requires careful planning, design, and implementation to ensure that it meets the energy demands of the intent area and is compatible with the existing power infrastructure. These are the two block diagrams. In the first block diagram, there are the four IDs which are connected to the RTU through the protocol called Modbus TCP. And the RTU is connected to the switch, and switch itself is connected to the mini cicada. So it means the RTU will communicate to the cicada through the protocol called IEC. There will be two networks. One is the operating network and the local network. And the local network is connected to IDs, and ID is also connected to RTU. The operational network facilitates communication between the central control and the mini cicada devices, which collects common rate fields and make them available to the control room. The local network enables communication between supervisory system and the feeder IDs. Analog value calculated are transmitted using either DNP3 protocol or IEC103 protocol, but there are no redundancy of the protective IDs. Each substation has two local supervisors, mini cicada, which is serves as a main and hard backup. In the next figure, the communication will be done horizontally for status indication and interlocks using IEC 61850 protocol, Goose protocol, which reduces the amount of cables needed for the communication among IEDs. Analog values will be sent through DNP3 since the existing minicicada equipment is not capable of working with the MMS protocol. The mini cicada equipment will serve as an interface between the IED and the central cicada. It is important in this configuration it will be possible to access the IEDs using the same network as the control center, which differs the previous architecture. These resources provide the real-time monitoring of monitored element and the help identifying quickly faults. The communication network will facilitate predictive and preventive maintenance strategies. So next is the result part. One of the objectives of the primary substation digitalization solution is to modernize the substation, replacing obsolete equipment such as electrochemical rays for the equipments in the greater processing and the function consisting with current technologies. Mainly it has a three types, the three parts of the generation, transmission, the distribution part. The power will be generated through renewables like solar power plant, hydropower plant, nuclear power plant, and it will be transmitted and distributed to the control center. The control center will itself transmit it to the consumer. So the consumers will be energy storage, battery management system, energy storage, or electric vehicle. Another different functional point in the proposed architecture that uses of the directional relay for protections. The point to consider is the change in the form of transform control and the parallelism function, which used to decentralized with the function in an IED for each power transformer, and now it is centralized. In the decentralized, there will be the separate controller for each, and in the centralized, there will be only one controller for each. So there, if there will be any damage, so we can rectify and we can replace it easily. These are the applications and advantages. Applications involve smart grid enables utilities to manage the load on the grid more efficiently by using real-time data from sensors and meters. It also integrates renewable energy sources such as solar and wind power more effectively into the grid. The advantages include an automated distribution grid can improve the reliability of power supply by reducing the duration and frequency of power outages. Automation of the distribution grid can reduce costs associated with manual interventions in the distribution system. An automated distribution grid can facilitate the integration of renewable energy sources such as solar and wind into the grid. Conclusion: the aim is to improve the monitoring of assets and the protection system in the distribution grid of electrical power MV and LV. MV is medium voltage and LV is the low voltage. For this purpose, a communication network has been established between the field equipments and the operator center. The modernization of substation equipment, protection logic, and the communication protocol will be carried out. Equipment is capable of locating faults in the underground distribution grid and monitoring multiple circuits has also been implemented. The electricity distribution grid will be safer, more reliable, monitored almost in real time, and equipped with the latest generation technologies. The end consumers will benefit from grids with greater availability and fewer interruptions. These are the papers which I have referred for this. You can go through this. These are the all IEEE members, and we complete our project, our today's topic. Thank you everyone.